I'm going to label this 1.5 part B, so it's the second part, second half of the video before you can do the homework and the free response questions. But we read stories. I don't know why it had to be a 3-page short story, but it's whatever. We start on the left side and we read to the right. That's what he's trying to get at with that question. So, and the same thing happens with graphs. We read left to right. So when we're looking at these problems, I don't care if you, because these are your notes, if you just use a marker or a highlighter or color, whatever you want. From left to right, where a function is decreasing, that means going down as we read left to right. So this interval from here to here is considered decreasing, and then here definitely going up, so not decreasing. This is staying the same or constant, and it's also going down over here. So before I move on, I want to point out the interval on the x-axis. I actually understand there's two different answers. Depending on what math book you read, they're going to use brackets to say that it's decreasing from -5 to -3. We give the x values for the portion that was highlighted. And I think you're used to it, but if you're not, let me explain that. We use this U symbol. It's not an actual U, so don't put a tail on it. But it's called union. That's why we make it look like a U. It looks like an onion. Let me just write that better. Union. It just means or. So it's decreasing from -5 to -3, or from 1, 2, 3, 4 to it stops decreasing at 6. Now, just so you know, you might see me write these answers with parentheses. So I'm going to just change colors because I've seen some math teachers, and there's like arguments out there actually from people who disagree with that you, like if you look at -3, it's decreasing to the left, but it's increasing to the right, which I'll kind of get to that in a second. And a person would just say, well, how can you increase and decrease at the same time? And a quick answer would say you can't. I'm not going to get into an argument for it. I'll accept both as correct. So whether it's parentheses or brackets, I'll accept both answers. But I'm going to go with what's the higher math people where they use brackets. So this function is it's the same graph, and I kind of already gave you the answer. It's increasing from -3 to 0. And let me just change colors one more time. This is a constant graph. Constant just means it's not going up or going down. It's staying constant from the x values from 0 to 4. And this next question kind of goes in between here. Should your intervals identified above, you have closed the use of brackets or open the use of parentheses. And this is, I'm just going to leave this open to you. It's your choice. I want to say that my answer keys on future quizzes and tests use parentheses. But if anybody's curious, I'm in the middle of getting my master's in math education. And higher level math books actually use brackets. So I'm good either way. I'm going to leave this up to you. Now the next thing to talk about is domain and range. You may remember domain from previous math classes as your x values and range as your y values. So if you look at the graph function above, it's the same for all three. We also read this from left to right. So as we look, I'm just going to look at this one because I have less stuff drawn on it. The first time this function is defined is at -5, and it's defined as I move to the right until I get to this x value of 6. So the domain believe I said was from -5, and it stopped being defined once we got to 6. Well, the range, we don't want to read left to right, because left to right were the x values. So the range, we just read from the bottom to the top. And maybe I should have color-coded this, but I think you'll forgive me. So the lowest y value that's defined is down here at y equals -3. It's defined, defined, defined. It even goes back down. We're not reading the graph, just so you know. We're just seeing when it stops being defined. And the top part that stops being defined is at y equals 5. I already forgot what the numbers were. I think it was -3 to 5. And we do need to, this has to be brackets. These must be brackets because they are closed. If anybody's curious, I've actually seen math teachers put a box around the graph, and that's what they use. So everything needs to fit inside of that box. And I can certainly see the appeal as to why people would do that. But you have to use brackets in this problem. Increasing and decreasing, the brackets are optional. Domain and range, in this case, the brackets must be there. A situation where one of these brackets might be a parenthesis is if this endpoint was an open circle. Then you would have a parenthesis there. Okay. As we move forward, I think you're pretty familiar with... Oh, I don't know why that happened. With function notation being your y value. So anytime you see, I'm sure you heard it over and over again years ago, that it's always the y value. So if we were to say y equals 0, so that's what f of x equals 0 means, where are all of these points located? Well, if I were to look at a graph where y is 0, it's a horizontal line, and it's essentially on the x-axis. So if we look at the next question where it's saying y is greater than 0, well, what kind of numbers are bigger than 0? Well, those are positive numbers. So I'm not going to shade. Well, maybe I could shade with a highlighter. Kind of a smart thing to do. That did not shade at all. Sorry about that. Get a highlighter and shade. There we go. It's everything that's above the x-axis. Above the x-axis. Versus if I said y is less than 0, those are negative numbers. And let me get a separate color highlighter out. Separate color highlighter. That would be anywhere you're below, negative values are below the x-axis. So as we're looking at this, I think I kind of ruined this picture because it wanted you to trace. I'll go back to blue and just use not a highlighter. So if we're asking where f of x is equal to 0, that's anywhere that we're on the x-axis. So the first time we're on the x-axis is at -3, this value, which looks like x equals 0, and then this value right here, x equals 6. So then, as we're answering this next question where the function is above the x-axis, well, it's not above the x-axis until we get past -3. So we definitely want to use parentheses here because it's greater than only, not equal to. So when would we use a bracket is what if this said greater than or equal to? Then we would want to use a bracket because it could be on the x-axis or above. But since the directions do not, let me get rid of that. And it is no longer above the x-axis once I get to x equals 0. But immediately to the right of x equals 0, it is above the x-axis again. And it stops once I get to this x equals 6. So notice that all of these are parentheses because they're strictly above the x-axis. If it said or equal to, we could just do a bracket from -3 to 6. So now how about being below the x-axis? The first time, again, we read this left to right. So -5 to -3. Now notice I'm using a bracket with -5 because it's defined and below the x-axis at -5. But it's no longer below the x-axis once I get to -3. So a parenthesis there. And then same thing all the way over here once you get to 6. And then 7 with a bracket because it is defined and below the x-axis there. So really the same question here, except this time I'm not giving you the option. Should you use brackets, a closed interval, or parentheses, the open interval? That depends. It depends on a couple different things. For one, is it less than or is it less than or equal to? Because if I made this problem less than or equal to, you better include x equals 0 here as well. You'd also include -3 and +6. It could also depend on being greater than or equal to. I gave you that example earlier as well. And it also would depend on a problem like this. Is it defined and below? Or if we had another example like this one, is it defined and above? That would be your indicator to use a bracket as well. So how about I teach the last one, domain and range, using the box method I talked about earlier. Well, if you use the box method and you fit everything inside the box, so every piece of the graph needs to fit inside the box, you can draw a box like this. I'm not a big fan of this method, by the way. I prefer reading left to right and the bottom to the top. So if you do the box, we're defined all the way to -5, all the way to 7. So that's your domain. Your x values are left to right. And your range is from the bottom to the top. So it's defined all the way down to -4, all the way up to +4. And now you should be ready to complete the next assignment. And for anybody curious, here's the answer keys method for explaining that. If you want to pause the video and copy this down, completely up to you as well.